In this video, we're going to take a look at significant figures. So let's start out by going over the rules first. I'm going to condense these from the sheet that I gave you in class. So the first rule, all non-zeros are significant. So anything not a zero is important to what we're doing, so those count. Any final zeros that are after a decimal are significant, so those count. So for example, zeros that are, that's 12.0, that counts. If it's 0.020, that last zero counts. And we'll look at some examples in a minute. Zeros that are between non-zeros, so any zero that is sandwiched is considered important. And then anything that's a placeholder is not significant. So let's take a look at some examples. I have 6 for us to look at. First one is 2,804 meters. The 2, the 8, and the 4 are all non-zeros, so those are significant. And in this case, the 0 is sandwiched, so it is significant for number 1. So we have 1, 2, 3, and 4 numbers total. For number 2, we have 2.84. There are no zeros in this, so that means all of the digits are significant, so we have 3 total. Now for number 3, we have 0.0029. The 2 and the 9 are most definitely important. However, the zeros that are before the 2 and the 9 are considered placeholders, so we do not count those as significant. So we only have 2 in number 3. In number 4, we have a similar situation going on. We have 0.003068. The 3, the 6, and the 8 are significant, so that's at least 3 digits. The zeros before the 3 are not significant. They are placeholders. The 0 between the 3 and the 6 is sandwiched, so it is significant. So in number 4, we have 4 significant figures. In number 5, we have 4.6 times 10 to the 5th. Your 10 to the 5th is just considered your placeholders. So the only thing as far as scientific notation goes is going by your rules. So 4.6, both of those are non-zero, so number 5 has 2 significant figures. And then number 6 is 4.06 times 10 to the negative 5th. Again, that scientific notation means that those are placeholders, but the 4, the 6, and of course the 0, because it is sandwiched, are significant. So there are 3 in number 6. Now, for purposes of this class, you will be adding, subtracting, multiplying, and dividing with significant figures. So let's take a look at adding first. You are going to look at the number of significant figures in each of your values, and you're going to go with the one that has the least number of significant figures. It's not looking at accuracy for this. We are looking just at precision. So do not worry about being 100% accurate for the purposes of significant figures. So here's your first one, 24.686, 2.343, and 3.21. So let's go ahead and put our significant figures down. In the first number, we have 5. All of those are non-zeros. In the second one, we have 4. Those again are all non-zeros. And in the third number, we only have 3 because those are again all non-zeros. So the least number we have is 3. That means your final answer can only have 3 significant figures. So let's just go ahead and write this out so that we can calculate our answer. So 24.686, 2.343, and 3.21. And we are just going to add those numbers up. You're welcome to do this in a calculator, but I do think that it is pertinent that you know how to do this longhand without your calculator, just in case. So 3, 6, that's 9. 8, 4, 1, that's 13. 6, 3, 2, 1, that is 12. 4, 2, 3, 1, that is 10. And then 2 and 1, that is 3. So right now we have 30.239, but again, we can only have 3 significant figures. So the 3, that's your first one. The 0, that is your second one. And the 2 is your third. So we need to look at that fourth number to see if we are going to round up or if it is going to stay the same number. And we are going to have 30.2 meters. So that is your first example. The second example, as far as adding goes, we have 6.201, 7.4, and 0.68. as well as 12.0. So again, let's go through, let's look at how many significant figures we have. In this first number, we have 1, 2, 3, 4. That 0 is sandwiched, so it does count. In the second number, we have no zeros, so we only have 2. In the third number, this 0 is before the decimal, before the number, so we only have the 6 and the 8 that count, so they're again 2. And then 12.0. Now this is at the end of your number, and it is behind the decimal, so it does count. So we have 3 here. Again, 2 is our smallest number, so our answer can only have 2. So let's go ahead and add these together. So we have 6.201, 7.4, 0.68, and I'm just lining up my decimals here, and then 12.0. Makes it a little easier to add if we are doing this freehand. So we have 1 in the outside, we have 8 behind that, we have 2, 4, and 6, so we have 12. Carry that 1. We have 6, 7, and 2, so we have a total of 16 there, and then we have a 1. So 26.281. Again, you can only have 2, so here's your first 2 digits. You look at that next one for rounding, and we should have 26 centimeters. Now let's take a look at one more. A little bit more difficult here. I have given you 3 different units. All of them have the same base unit of meters, but just like in the conversions video, we are going to change it to where they are all meters. Okay, so 1.6 kilometers, that's 1, 2, 3, so that's 1,600 meters. 1.62, that's just going to stay what it is. And then 1,200 centimeters becomes 12 meters. Okay, so now we have our new numbers. We still only have 2 here, we have 3 here, and we only have 2 here. So that means our final answer can only have 2. So let's go ahead and write these down. We've got 1,600, we have 12, and we have 1.62. Now when we add these together, the 6 and the 2 drop down. We have 1 and 2 makes 3, 1, 6, and 1. Now in this case, because we can only have 2 significant figures, when we look at this, only the 1 and the 6 are included. So that means even though it's completely inaccurate, 1,600 meters is our answer as far as significant figures go. So again, we are not focusing on accuracy here, but we are looking at precision. Let's go ahead and move forward to subtracting. Similar concept here. You're looking at the least precise value, and you are going to subtract. So in this case, we have 10.8, and we are going to take 8.264 from that number. So our 10.8 will go in the top, and then we are going to subtract 8.264 from that. Now, in this case, we need to count our sig figs. 1, 2, 3, 4. In the first one, there are no zeros. And here we have a 1 and an 8, but the 0 is sandwiched, so it has 3. So that means your final answer needs to have 3. Now, anytime that we are looking at subtracting, if you are doing this longhand, you do need to remember how to do this. So 4 from 10, we have 6. 6 from 9 is 3. 2 from 9 is 7. 8 from, let's cancel and carry our 1 over. 8 from 10 is 2. So we need 3 sig figs for this. So here's 1, here's 2, here's 3, and we need to look at that last number to know if we round, which we do. So 2.74 grams. All right, let's look at a couple more subtracting problems, and then we'll move forward to multiplying and dividing. In this case, we again have meters. So we have 475 and 0.4168. So 475, and then we have 0.4168. Again, you are welcome to use your calculator, but I do think it's incredibly important that you know how to do this without a calculator. We have 4 in the first one. Again, that first 0 does not count as an important number. We have 3 in the second one. So 3 is our important number. So again, let's go ahead and count off, move over all of these numbers quite a bit. And here's that last one for the 8. 8 from 10 is 2, 6 from 9 is 3, 1 from 9 is 8, 4 from 9 is 5, and then 0 from 4 is 4, and then we leave our 7 and our 4. Now again, this can only stay with 3 sig figs. So if we look, here's 1, here's 2, here's 3, and we look at that last number to see if we round, and we do. So again, even though it is inaccurate, 475 meters is our answer with the correct number of significant figures. All right, multiplying and dividing, and we'll get through this as quick as we can. Same thing, we're looking at the least precise value involved. And as far as multiplying and dividing goes, we are just going to multiply our units together. So here we have 3.22, that's 3, and we have 2.1, that's 2, so our answer can only have 2. So 3.22, and we have 2.1, and we are multiplying here. So we have 3, 2, 2, we have a placeholder, and then we have 2 times 2 is 4, 2 times 2 is 4, 2 times 3 is 6. We'll add those together. 2, 6, 7, 6, and we have 3 decimal places. So 6.762. Again, we can only have 2. So here's our 2, here's our number we look at for rounding, and we have 6.8. And again, for our units, we just multiply those. Another example with our multiplying and dividing, we have 131 that has 3, 2.3 which has 2, so our answer can only have 2. So 131 and 2.3, 3 times 1 is 3, 3 times 3 is 9, 3 times 1 is 3. We need a placeholder. 2 times 1 is 2, 2 times 3 is 6, and 2 times 1 is 2. Again, we are going to add this up, and we get 1 decimal place for this, so we have 301.3. Again, we can only have 2 significant figures. So in this case, because it rounds to 300, and there's not really a good way to make 300 have 2 sig figs, we need to write this in scientific notation. So 3.0 times 10, and that's 1 2 places, so 10 to the second power, and that is centimeters squared again. All right, one more example for multiplying, and we'll look at dividing. So multiplying, we have 5.761, and we have 6.20, so we have 4 here. Again, this is after the decimal and after a number, so this is 3, so our number can have 3 in this case. So 5, 7, 6, 1. And again, you are welcome to do this in the calculator. For this one, I'm going to do this in the calculator just to save a little bit of time. So we have 5.761 multiplied by 6.20, and we get 35.718. So 35.718. And again, we need 3 here. So here's 1, here's 2, and here's 3. We're going to look at that next number. So 35.7, and again, we are just putting our units together. So this is newtons times meters. Now, when you actually get to multiplication and division with your units, you do not have to worry about consolidating them into one single value. We call these derived units, so you could have more than one unit in one place. So let's go ahead and move forward and look at dividing. Same thing here. Least precise value. So we have 36.5, that's 3. And we have 3.414, that's 4, so our number needs to have 3 in it. So we are looking at 3.414 into 36.5. Now again, you are welcome to use a calculator, but I do think it would be pertinent for you to learn how to use longhand, just in case anything were to happen. You never know. So if we actually did this in the calculator, you actually get 10.69. We need 3 of those sig figs. So here's 1, here's 2, here's 3. So we are going to do 10.7 because that 9 is going to round up for us. And again, because we have differentiated units here, we can just plug those in as meters divided by seconds. That should be a familiar unit to you. Couple more problems. 20.2, we have 3. 7.41, we have 3. So 20.2 divided by 7.41, you get 2.726. And that goes to 2.73.